Hello, and welcome back to Introduction to Astronomy. And in our previous segment, we were talking about Newton's first law of motion, and Newton came up with a second law of motion, which is the mathematical one. So you've already seen this formula, force equals ma. So F is the force, m is the mass, a is the acceleration. So a force will cause a mass to accelerate. So that was his second law of motion. And so we also want to have a demonstration of this. And again, this is a thought demonstration. So get out the ping pong ball. What color was it? Blue? Yeah, I think it was. So you got your blue ping pong ball. Okay, now you're going to put it on the table. Now this is even better if you got a real ping pong ball. So go get one. Put me on pause. Got it? Okay. So take your ping pong ball and then flip it with your finger. And then notice what happens to the ping pong ball. So the ping pong ball shoots out, okay, because it experienced a what? So when you flip it, you're applying a what to the ping pong ball? A force, okay? And then when it shoots out, how would you, what kind of motion is that when it shoots out? So which of the three letters in that formula are we talking about? A, okay, so it accelerated. It had a zero speed, and now all of a sudden it's got this new speed, so its speed changed, and that's the definition of an acceleration. Now, where's the m? So m would be the mass of the ping pong ball, which is very, very small. Okay, now let's try something that would be more painful, okay? So let's pretend now that we get out our pink bowling ball, okay? And now we're going to flip it like we did before. So we're going to apply the same amount of force to the bowling ball as we did to the little ping pong ball. Well, what's going to happen? Well, number one, you're probably going to break your finger. So don't do it, okay? So don't do this experiment. It's a thought experiment. You should know what's going to happen if you flip that bowling ball. Okay, the bowling ball's not going to move very much. So, question is, why? So what we could do is let's write the formula. Excuse me. So let's write our formula, force equals ma, and so this would be a force causes a mass to accelerate. All right, now let's write it again, but let's do it for the bowling ball. So for the bowling ball, let's put a big, gigantic M, and what we'd like to know is what would the A do in order to compensate. And so in order to understand this, let's go back to algebra. And you should know that 4 is equal to 4 times 1. Doesn't get any easier than this. Okay, but you should also know that it's equal to 1 times 4. You get the same number. So do you notice that a big number multiplied by a small number is the same as a small number multiplied by a big number? So in this case here, do you see that the m got big? So what does the a do in order to compensate? It's going to get small. So what did you notice that the bowling ball did? It did not move very much. So the acceleration of the bowling ball was much, much smaller than the ping pong ball. Now let's do it for the ping pong ball. How should I make my m for the ping pong ball? Okay, it should be really, really small. Okay, but what would the a be for the ping pong ball? It would be very, very large. So a small number times a big number could be the same as a big number times a small number. So the ping pong ball is going to have more acceleration than what the bowling ball is going to have. Okay, let's try another kind of problem here. Okay, a force acts on a mass, which causes the mass to accelerate. Force equals ma. Okay, if twice the force is applied, what would happen to the acceleration? So let's do an experiment before you solve the problem. Do you remember that you had the ping pong ball and you gave it a flip? Okay, take the ping pong ball, but give it a double flip. So hit it with 2 fingers instead of just 1 finger, and observe what does the ping pong ball do. Okay, and you'll notice that it shoots further than it did before. Okay, so what does that tell you about its acceleration? It was greater. Now, can we figure out how much greater? Yeah. So we're going to write down Newton's second law of motion, force equals ma, and we're going to double the force. So we're going to double the force, so that means 2 times the F. Well, there's something you should remember from algebra, that when you've got an equation and you multiply one side of the equation by, let's say, 2, then what else do you have to do? You have to multiply the other side by 2. So that 2 times the force would produce 2 times the acceleration. So that's an example of a type of test question that I would give to my astronomy students. So not too mathematical, but you got to know how the formula works. Okay, when we come back, we're going to talk about Newton's third law of motion.